All right, we're going to kind of have a little bit of a review over radicals. We worked on these a few days ago, but then we kind of transferred over, worked on Pythagorean theorem. So now we're going to come back to the radicals. Okay, so simplifying a radical, you're going to want to do your factor tree. So 18 times 10, and then just keep breaking that down to your prime factors. 9 will go 3 and 3, and then I'm going to bring down these other prime factors. Okay, you are looking for pairs that match. So there's a pair of 3s that can come out, a pair of 2s that can come out, and then root 5 is left over. So this is 6 root 5. Okay, number 2. Now I already have a 5 out front, but then I'm going to take 512 and divide it. It's definitely divisible by 2 because it's even, but I'm going to go with 8. This is divisible by 8. 8 times 64. And then I'm going to break this down. So 8 is a 4 and a 2. 64 is 8 and 8. We're going to have lots of 2's on this one. Okay, now my 8 is 4 and 2. And then that 4 is a 2 and 2. So if it's okay, I'm just going to go 2, 2, 2. Because I know it's a 4 and a 2, and then those would break down. Okay, so now I need pairs. Well, here's one pair. Here's a pair. Here's a pair. Here's a pair. So I already have the 5, and then we got 1, 2, 3. We got 4 2's, and then a square root of 2. So 2 times 2 times 2 times 2 times 5 is 80 root 2. So that's simplest radical form. Okay. When you add, you need to have basically like terms. They need to match. So these both are root 6's. So this would be like a negative 1 root 6. So this together would be a negative 3 root 6. Okay, now these are not like radicals. They don't match. But if I can do something with the 112, I might be able to make them match. And this is 7 times 16. And then 16, 4 times 4, and bring that 7 down. Oops, needs to be a 7. And then these I've got are 2's. Okay, so there's a pair of 2's, there's another pair of 2's, and then my 7 is left over. So the 2's, another 2, and then root 7. So this is 4 root 7, and then I have plus this root 7. So this would be 5 square root of 7. Okay, so then multiplying. Now, unlike adding where you have to match, multiplying you do not. So I can just multiply those radicals together and make that square root of 30. Now that one is finished. I don't have to do any simplifying on that. If I do my factor tree, what happens is I have a 3, a 2, and a 5. So I don't have any matches, so I can't simplify that 30. So it's just going to stay square root of 30. Okay, now this one, root 6 times negative 5 root 20. Well, okay, negative 5, and then I'm going to multiply my radicals together. So 6 times 20 is 120. So 120, I'm going to break this down. Get a 12 and a 10, 4, 3, a 2, and a 5, and then this 4 is going to go 2 and 2. So I have a pair of 2's that I can bring out front, and then what's left over is a 3, a 2, and a 5. So that's going to happen to be a 30 again. So negative 10 root 30. Okay. Number 7. This one we're going to distribute. So I can have 3 square root of 6. Okay, now that 3 is not in a radical, so that's not going to go underneath with the 6. It's going to be out front. And now root 6 times root 3 is square root of 18. Okay, so 3 root 6 plus, now 18, I can simplify. A 9 and a 2, and then my 9 is a 3 and a 3. So pair of 3s, and I can bring out my 2. 6 is just a 3 and a 2, so nothing I can do with that. And now that I have that simplified, I was able to simplify a little bit, but they still don't match as far as their radicals, so I can't add them together. So this is what you will have. Okay, so that's kind of a quick reminder about how we can work with radicals. And I will see you all